Okay, this is the Nature of Matter lecture number 1 over atoms, elements, and the periodic table. Everything's made up of atoms. Atoms are the basic unit of all matter. And right here, actually, we have a model of an atom, okay? Atoms are everything's made up of atoms, but atoms are made up of protons, neutrons, and electrons, okay? Protons have a positive charge, neutrons have no charge at all, and electrons have a negative charge, okay? And all atoms have an equal number of neutrons, protons, and electrons, okay? So if this atom has 6 protons, it should also have 6 electrons and 6 neutrons, because all atoms have an equal number of protons, neutrons, and electrons, okay? Protons and neutrons are found here in the center, and that is called the nucleus, okay? Protons and neutrons are in the nucleus at the center of an atom. And electrons are found along the outside of the nucleus of an atom. They're in shells or orbitals, we might call them. And they just float around the outside of the nucleus of an atom. They actually orbit the nucleus of an atom, just like we orbit the sun here on Earth, or the moon orbits Earth. Okay? The electron gets its own special shout out because it's got its own thing going on. The electron, like I said, are arranged in shells or orbitals just outside the nucleus of an atom. They are always going around the nucleus in motion. They never stop. They're always orbiting the nucleus, okay? In an atom, let's say this is the nucleus, this is the first shell, and this is the second shell, okay? In an atom, in the first shell, we can have up to 2 electrons, okay? The first shell of an atom carries 2 electrons. In the second shell of an atom, we can have up to 8 electrons. We don't have to have 8, but we can have up to 8. See, we can stop at 6, and there's still room for 2 more, but the second shell of an atom can carry up to 8 electrons, okay? And whatever shell is on the very outside, it could be the 3rd, 4th, 16th shell, the electrons in the outermost shell are called valence electrons. Here are 3 different models of an atom. This model right here, you can see there's a nucleus, there's an electron. You can see the electron is going around the nucleus of the atom. What you can't see is the individual protons and neutrons in the nucleus here. It's just one solid nucleus, but that's actually a number of protons and a number of neutrons in there, okay? So it's not an excellent model, but it is a model of an atom. Then you get to the model in the middle of the screen here. We can see the individual protons and neutrons. We can see the individual electrons. We can see the electrons are orbiting the nucleus in several different ways, not just one way. And then we have the Bohr model, okay? Now, the Bohr model looks simple, but it's actually very, very helpful. It's helpful in being able to see the exact number of protons and neutrons in the nucleus and the exact number of electrons in their shells in an atom, okay? So here we see random shells. We don't know which is the first, second, third. Here there's just one shell, but here we have the first shell. It's got 2 electrons. We could have another shell with up to how many? 8 electrons. We could have another shell. We could have another shell, okay? So we will be very comfortable with the Bohr model in our class. This is the periodic table of elements, and it is an organizational chart that contains all known elements, okay? Elements can be represented by 1 or 2 letters, all right? So oxygen is represented by O, and let's see, iron is represented by capital F, lowercase e, right? And so, it could be 1 or 2 letters. An element is a pure substance made entirely out of one type of atom, okay? So if I have an atom that has 8 protons, 8 neutrons, and 8 electrons, that is oxygen, okay? Now, an element is a pure substance made entirely out of one type of atom. So I could have a bunch of oxygen atoms, and then I'll have the element oxygen. But if I had a mixture of 2 different types of atoms, then it's not an element, it's a compound. But we'll get into that a little bit later. All you need to know here is this is the periodic table of elements. It's organized into different sections. You can see the different colors. There's the noble gases and the alkaline metals and things like that. And elements are made out of one type of atom. They're a pure substance made entirely out of one type of atom. Let's take a closer look at a square on the periodic table. You can see here magnesium, and there's some numbers on here that we're going to take a look at. I did want to point out that about 99% of the mass of living things is made up of just 6 elements: carbon, hydrogen, oxygen, nitrogen, phosphorus, and calcium. And the other 1% of elements that living things are made up out of are called trace elements, and that could be zinc, mercury, iron, things of that nature. But mostly we're carbon, hydrogen, oxygen, nitrogen, phosphorus, and calcium, okay? 60% of the human body is water, and that's just hydrogen and oxygen. So 60% of humans are just hydrogen and oxygen there, okay? So let's look at magnesium here on the periodic table. You can see 2 numbers. You have the number up here in the top left corner, and we have the number here at the bottom. We also have the 2 letters here, Mg, that represent magnesium. Remember, an element can be represented by 1 or 2 letters, okay? Let's start with the atomic number. The atomic number is found up here in the upper left-hand corner. It could be in the right-hand corner depending on what chart you're looking at. They're not always the same format, but most of the time they'll be in the upper corner. In this case, it's the upper left-hand corner. This is the atomic number. The atomic number tells us how many protons there are in an atom of that element. So in magnesium, there are 12 protons. Now remember, there should be an equal number of protons, neutrons, and electrons. So if there are 12 protons, there should be 12 neutrons and 12 electrons. There should be 12, 12, and 12. Okay? Now the number here at the bottom, this decimal, 24.305, that is called the mass number. Okay? That's the mass number. The mass number tells us the total number of protons and neutrons. Okay? So if there's 12 protons in magnesium and 12 neutrons, this should just be 24, right? But it's a decimal. This is a decimal because of a little something called an isotope. Okay? An isotope we'll talk about a little bit later in more detail, but it's basically an atom of the element that has a different number of neutrons, either 1 more or 1 less, and in some cases 2 more or 2 less. And this is a decimal because it's an average of the percentage, or it's an average of the frequency of the isotopes of an element, okay? So because the number is 24.305, we know that more frequently there is an atom of magnesium that has 13 neutrons instead of 11 neutrons, right? If 11 neutrons occurred more frequently, then this number might be 23.997 or something like that, okay? All right, we'll talk a little bit more about isotopes here in a minute. All elements have different properties, and all elements are made of atoms, okay? And all atoms are made up of subatomic particles, protons, neutrons, and electrons. So the question is, why do different elements have different properties if they're all made up of protons, neutrons, and electrons? Well, that has to do with the electrons and how they interact with each other and how their shells overlap and react with each other. And it affects how they interact with other atoms and how they participate in chemical reactions. So oxygen is very different from sodium, and it's because their electrons interact very differently. Okay? It all has to do with the electrons and the outermost shell, the valence electrons. Okay? Here are our isotopes. Isotopes are just atoms of the same element that have a different number of neutrons, okay? Right here in the middle, you can see an atom of hydrogen, okay? It has 1 proton, 1 neutron, and 1 electron, and that's right because its atomic number is 1. However, it could have 1 more neutron, or it could have 1 less neutron, in which case we end up with isotopes. So, the one in the middle, this hydrogen here, that is a standard hydrogen atom. This on the right is an isotope, and this on the left is an isotope. Okay? If there were no isotopes at all, and we were looking at hydrogen on the periodic table, if there were no isotopes, then the mass number would just be 2. Because it would be the number of protons and the number of neutrons. 1 proton, 1 neutron, it would just be 2. But because we have isotopes, sometimes there's 2 neutrons and sometimes there's 1 neutron. That's why we have that decimal. So it's probably like 1.2 something, something, something. I really have no idea. But we have a decimal because of the existence of isotopes. So your first project of the year is to create a model of a atom of your choice, an atom of your choice. The rubric is available in Google Classroom, but here's a quick little overview. It has to include the nucleus. It has to show explicitly the protons and neutrons and their charge. You have to show the electrons orbiting in the shells. It has to be greater than atomic number 8, which happens to be oxygen. So anything beyond oxygen you can make. It has to be 3-dimensional, okay? And it is worth 50 points. So go ahead and check out the rubric on Google Classroom, and then you can get started working on your first project for the year.